Alright, Geometry, Chapter 10, Section 7, Circles in the Coordinate Plane. So if you have a circle like this and its center is at the origin, then you can find the radius by saying we go over this much, an x amount, and then up a y amount. And the radius is the hypotenuse, so we would have basically the Pythagorean theorem here, x squared plus y squared equals r squared. Alright, well, if the center is not at the origin, then we would be moving the x a certain amount. Then we have 2 points like this, right? So this point is x and y. The other point, the center, is h and k. So x and y is a point on the circle. H and k is the center. So this point is xy. The distance from here, if we go down the y-axis, then that means that's y minus k. So this amount minus this amount right here. If we move the x-axis, then that's x minus the h amount. So that leaves us with this formula. Basically still Pythagorean theorem, just we're using coordinates for that. Okay, so we want to write the standard equation of each circle for this circle right here, and then for a circle with a center of 0 and -9 and a radius that's 4 and 2. Okay, so for this circle right here, we'll always start out with our formula, okay, and then h and k is at the origin, so that's going to be 0, so plug in 0 there, and the radius here you can see is 3, so I'll put in 3 for r, and then simplify that, and that leaves me with x squared plus y squared is 9, and that would be in standard form. If we have a center at 0 and -9, then I'm going to replace h and k with 0 and -9. Now, pay attention here with this negative, right? Because that's going to be a -9. That's where the mistakes are going to happen here. Okay, what time you have a negative, that's a warning sign. And then the radius 4.2, simplify that, and this is in standard form as far as I can simplify that. Okay, if we have a point 5,6 on a circle and the center at -1 and 3, we want to write the standard equation for this circle. So now we don't have what r is, but we can find that. Either we use Pythagorean theorem here, or you could start with the formula, right? Because it's basically Pythagorean theorem and they put in the points, so we find the square root of all this, so, or set it up as the distance formula, one way or another. Find the radius, right? Either plug that in here, distance formula, all of that is the same thing. And then solve this for r, and you get the radius from here to there is 5. Now you could have also seen here we have 3, 4, right triangle, so that's 5. Once you have the radius, now we're going to use one of these points. Sorry, no, you're going to use the center, okay, and you're going to plug that in for h and k, right? And then simplify this down as much as you can. Negative minus a negative is going to give me a plus. So that is in standard form right here. Oh, that didn't work very well. Let's move that. There we go. Okay, find the center of the radius of each circle, then graph each circle. So if we have a circle whose standard equation is this, the center is basically given to us in here. Now remember that formula is x minus something. So that's minus -4 makes that a plus. So we have here the center at -4 and 1. Okay, for the circle that has this as its endpoints of the diameter. Okay, first we're going to find the midpoint between these, because for the diameter, halfway in between the endpoints of the diameter is the center of the circle, right? And then once you have those, we can find the radius, and once you have that radius, now we can find the center and graph that using a compass. You might see an application like this to measure where an earthquake happened. They need 3 circles, so 3 measurements, and then where those three overlap, that's where their epicenter is. So if we know one epicenter is 7 miles away, and we have that point, we make a circle with a radius of 7. One's 4 miles away, make a circle with a radius of 4. One's 5 miles, make a circle with a radius of 5. Where all of three of them overlap, that's where the epicenter is. There you go. Good times. Check in again next time.